TCP IP. Who doesn't know what TCP IP means? Well, most of us don't know. TCP IP is a protocol, just like NetBEUI or AppleTalk or IPX/SPX. But TCP IP, which by the way stands for Transmission Control Protocol, Internet Protocol, is the most popular protocol. I had to think about that for a minute because I want to get in trouble. When I use superlatives, I always get in trouble. It is the most popular protocol in the world right now. TCP IP, unlike most other protocols, requires substantial configuration, though. TCP IP is also considered a lot slower than other types of protocols. If you want to use NetBEUI, you pretty much just install NetBEUI on your computer and you don't have to do anything to it. If you want to use IPX/SPX, you pretty much just install it and it works. If you want to use TCP IP, you're going to have to be doing some substantial configuration. Well, why would anybody want to use a protocol that requires all this configuration? Well, TCP IP has two big benefits. Big benefit number one, it was designed by the United States government, and as a result of that, it's free. If you want to use NetBEUI, you've got to get Microsoft's permission. If you want to use IPX/SPX, you've got to get Novell's permission. If you want to use AppleTalk, you've got to get Apple's permission. Anybody can do anything they want with TCP IP because it comes from the United States government. It's free, yay! The other neat thing about TCP IP is that it's what we call a routable protocol. When you think about the internet, people like to say the internet is this one big network. It's really not. The internet is really a gazillion of little tiny, teeny networks that are interconnected. This interconnection through these big boxes called routers is the secret to what makes TCP IP so popular. The way TCP IP works is a little bit different than other different types of protocols. With TCP IP, every computer in your network gets a number. This number, it's actually 4 numbers separated by 3 periods. Each number is known as an octet, and it goes from 0 to 255. Each one of these numbers is absolutely unique. No two computers on the network can have the same, what they call IP address. Now, within the internet, that's a great big network. Every computer on the internet, listen carefully, every computer on the internet must have a unique IP address. There's no two computers on the internet that share the same IP address. Pretty neat, huh? So, this ability of being free, plus this ability of being routable, and using these IP addresses to do this neat routing thing, has made TCP IP the protocol when it comes to the internet. In fact, it's so popular that not only do computers hooked to the internet use it, but even if I have a small home network, I'll probably be using TCP IP. So, the best way to understand TCP IP is just to kind of dive in and see how to do it. So let's go into my network neighborhood and let's take a look at the TCP IP properties. I'm laughing at myself. I'm showing my age. In Windows 9X, it's My Network Neighborhood. In Windows XP, it's My Network Places, and I had the audacity to say it wrong. We're in My Network Places. Okay, so what I've done is I've highlighted my Internet Protocol. I just clicked on my Internet connection, selected Properties. Now I clicked on Internet Protocol, TCP IP, and I select Properties. Welcome to the world of TCP IP. So let's talk about a few things here. First of all, let's go ahead and talk about this. Automatic settings, which we'll talk about later. At this point, I want to do it the hard way. It says use the following IP address. Now I'm going to type in a arbitrary IP address. IP addresses are broken up into 4 octets, and each octet is a number between 0 and 255. So this number would come from my systems administrator. Now, the problem that we have is that in a TCP IP network, I have a bunch of computers that are in their own little local area network, but then I also have a router which hooks me to the internet. The problem is I want to be able to use TCP IP just to talk among myself as well as talk to the internet. So the problem is I have to come up with some way for my computer to go, this IP address is for a computer on my network, or this IP address is for a computer that's not in my network. And the magic is the subnet mask. The subnet mask consists of numbers between 0 and 255. In almost all cases, the number is going to be either 0 or 255. Wherever you see a 255, the number has to be exactly the same to be in the local area network. Wherever you see a 0, the number can be different. So let's say I want to connect to a computer called 192.168.2.7. You see that? Because that IP address is the same where the 255s are, it's only different where the 0 is, that computer is on my local area network. So in that case, I'm going to be sending directly to that computer. That's how my computer knows to talk to it directly. The default gateway is nothing more than the IP address of my router. And it's going to be on my network. They almost always end with the number 1, but there's no law of physics to that. It just tends to work out that way. So what would happen, let's say I want to send something to a computer 192.168.4.44. You see where the 255 is? That number is different. As a result of that, by looking at the subnet mask, my computer would not try to talk to 192.168.4.44 locally. It would simply send the data out to the default gateway. The default gateway is a router which is hooked to other routers, and they have very, very powerful brains inside of them that knows how to get that information to the proper system. So we count on them to take care of that, and they do a really, really good job. So the IP address is your individual address for your system. The subnet mask is used to determine whether its packets are to be sent within the local area network or to be sent out to the default gateway. The default gateway is the router that hooks your network to the internet. Now here's an interesting question. What if my network was not hooked to the internet? Would I need a default gateway? Absolutely not. In fact, there's a lot of TCP IP networks that are not hooked to the internet, and they don't have default gateways. They can only send to each other within their own local area network, but they don't have to have